Hello everyone, my name is Marcus Kander. I'll be explaining today how to solve dynamic problems that involve tension and springs. For this question, you are asked to calculate the tension of a system in static equilibrium. The question tells you that the spring has a K value of 60 newtons per meter and has been stretched 25 centimeters from its rest position. The first step to solving this question is to draw a free body diagram. I want to highlight for you some of the key forces acting on this box. First, you have tension from the ropes, which you want to break into their X and Y components. Second, there is Fg, the force of gravity, which acts straight downwards. Third, there is Fh, which is the spring force. To determine which direction Fh is acting in, take a look at the diagram. The question tells you the system is in static equilibrium. Over here, you have the ropes, which are trying to pull the box up. And over here, you have the spring force, which is trying to pull the box down. Because it's trying to pull it down, Fh will act straight downwards. The second step to solving this question is to set up a net force equation in the x and y direction. In the x direction, your equation should look like this. The x component of T1 and T2 are equal because the system is in static equilibrium. In the y direction, your equation should look like this. On one side of the equation, you have all the forces that are acting upwards on the box, which is the y component of T1 and T2. On the other side of the equation, you have all the forces that act downwards on the box, which is Fg and Fh. Now that you have your equation set up, isolate for either T1 or T2. It doesn't matter which one you choose, you're going to get the same answer either way. Once you isolate it, either T1 or T2, you will substitute it into the other equation to find the other missing variables. Today I'm going to be isolating for T1 by dividing both sides by cos 60. After I do that, I'm going to plug T1 into the y direction equation. If you look here, you'll find that we have sine 60 divided by cos 60, which if you remember from your trig identities, simplifies to tan 60. After you do that, just factor out a T2 just to simplify the equation. Before you carry on with your calculation, I should mention here that Fh is equal to K times X, where K is the stiffness of the spring in newtons per meter, and X is the stretch or compression of the spring in meters. So before you plug in any values, just make sure you convert the 25 centimeters, which was given in the question, to 0.25 meters to make sure all your units are consistent and accurate. Then, just divide both sides by cos 45 multiplied by tan 60 plus sine 45, which is the answer you found earlier. After you do that and calculate everything and plug in everything in, you'll find an answer for T2 should be 15.5 newtons. The last step in solving this question then is to plug T2 back in the x direction equation to get T1. Your final answer for T1 should be 21.9 newtons. That's it for this video. Thank you so much for watching. If you have any questions or want me to clarify anything, please leave me a message in the comments and I'll respond to you as soon as possible.